Good morning, guys. We are going today do together the Relating Distance and Apparent Motion Lab. Because I can't figure out how to use the technology, you are going to look at Einstein while we talk about the background information about this particular lab. And then I am going to do the lab for you, give you the data, and then you're going to complete the answers on your own. So the background information says this: when observing an object move past you, there are two factors that affect its apparent motion or how you perceive it. That is really important. It's not its actual motion, it's how you perceive it or how the motion appears to you. It's apparent motion. The first factor is the speed of the object. Its speed is visible to you and you call it fast or slow in relation to other reference objects. The second factor that affects the apparent motion of an object is its distance from you and from the objects around it. So in this investigation, you are going to examine how the distance of each planet from the Earth affects its apparent movement in the sky as observed from the Earth. So again, it's not its real movement, it's its apparent movement, how we perceive it from Earth in the sky. Okay? So here's what happens. We are asked to take a piece of paper, which I have here, and cut it in two, and then tape it together. So that's what I've done. You are then supposed to tape it to the baseboard. Well, I didn't want to tape it to my baseboard, but I set it up as best as I could against the wall, okay? You are then going to take four circles, which I have here, that are 5 centimeters in diameter. All right, label 1A, 1B, 1C, and 1 the Earth, which I have done. Then we are going from this point, the edge of our paper here, we are going to take planet C and move it out exactly 20 centimeters. Now remember that I don't have a meter stick. So I'm guesstimating here about where it should be, and I might move it a little bit so that you can see. And I'm also doing it from the middle of the planet. Okay, we're supposed to take planet B. And by the way, do you see my board here, the plank of my floor? I'm doing it right along that line, all right? So B we're supposed to put at 40 centimeters. So I think this is probably not 20. Let's move it out like that. And this one at about 40. All right? And we would measure this if we were doing it for real and if I had a meter stick. You're going to put planet A at about 80 centimeters. And then you're going to put planet Earth at about 100 centimeters. So that is what it would look like. Okay? Keep my fingers out of the way. Okay. Then it says to take planets A, B, and C and move them parallel to the wall 10 centimeters. So their actual movement is 10 centimeters. Oops, sorry. So we are going to move it over 10 centimeters. Here's B. We're going to move it over 10 centimeters. Let me move the paper clip. And A, we're going to move over 10 centimeters. So that our setup should look like what's on the second page of your notes, which is that diagram. Okay, we started out with them all lined up in a row. We moved planets A, B, and C over 10 centimeters, and now parallel to the wall still. And that's how we have this set up. Okay? Then it tells us to take our meter stick and through the middle of planet Earth and planet A, we are going to take the meter stick and extend it to our paper on the wall and put a dot. They've labeled theirs for planet A, dot A. Do you see that? So what we would be doing is taking our meter stick in the middle of Earth, in the middle of planet A, and extending it, I think I'm pretty darn close there, and extending it to the wall and marking a dot there, A. All right? Then do the same thing with B and C. And you see I've already done that. Here would be, I'm sorry, I'm probably making you dizzy. Earth and B, and extending it and put right there, put the dot. From Earth and C, and extending it and put the dot. Okay? Now what you are supposed to do, you don't need those planets anymore, is that you are supposed to measure from this point, which I made be the end of my paper, to point A and record it in your data table. You are supposed to take this point and record to point B, and then take this point and record to point C. Okay? So I am going to turn off the video for a minute. I am going to get my data for you, and then I'm going to go over a couple of the questions with you also to give you some hints. So be prepared to watch part 2.